Zeal Education Society, redefining excellence.
Hello, good morning to everyone. Myself Dr. Mahadev Unde, Professor, Zeal College of Engineering and Research, Pune. In the previous video lecture of the Basic Electrical Engineering, we have learned whenever alternating current flows through pure inductive circuit. We have seen the current equation, then the voltage and current waveforms, power waveform, then the phasor diagram and power consumed. Now in this video lecture we are going to learn the whenever alternating current flows through pure capacitive circuit. This circuit contains capacitor alone. So AC through pure capacitor. C. Let us have let the alternating voltage is applied to the circuit having capacitor only. So the voltage is V, small v equal to V max sin omega t. Say this is the expression 1, and say this is C, the current small I, current coming is small I, and voltage drop across capacitance is Vc. So when the alternating voltage is applied across the capacitor plates, it gets charged, and let C capacitance of capacitor in farad, Q charge on capacitor at any instant. At any instant. Q equal to CV. Therefore C, what is V? V max sin omega t. But current I is given by I equal to dq by dt. Therefore I equal to dq upon dt equal to C Vm derivative of sin omega t with respect to dt. So I equal to omega C Vm cos omega t. So this can be written as Vm upon 1 upon omega C cos omega t, that is equal to Vm upon xc, and cos omega t can be written as sin omega t plus pi by 2. Thus small I equal to I max sin omega t plus pi by 2. Where current I will become maximum when omega t plus pi by 2 sin equal to 1. Small I equal to I max equal to V max upon xc, where this is equation 2, where xc equal to 1 upon omega c equal to 1 upon 2 pi fc ohm is known as capacitive reactance. So therefore x is inversely proportional to frequency. X is inversely proportional to frequency. Therefore, if this is the frequency on x-axis and x is on the y-axis, that is curve is like this. Okay, this is the origin. See the waveform from equation 1 and 2. It is observed that current leads the voltage by pi by 2. Therefore, say the waveform T or theta origin. Now say when t equal to 0, that is at the origin, if you put t equal to 0, voltage will be 0. So the equation 1 is the reference waveform, reference quantity, and therefore we can show it like this. Say this is voltage waveform. Okay. Then current is from equation 2. When t equal to 0, current becomes maximum. Current is maximum and it has a positive value. That means it will start somewhere from here on this side. At t equal to 0, it has certain positive value. So this is the current waveform. We have assumed the magnitude of current is little bit less than the voltage. Okay, so this is current expression, this is voltage expression. Now we will see the phasor diagram. Now assume current as a reference vector. This is phi. Remember, phasors are always denoted by the RMS values. This is R. This angle is 90 degree, and how to observe? Always observe the CCW direction. So the current is leading. The voltage by pi by 2. Or this can also be shown like this, taking current as a reference vector. So this is the current and this is phi. This is angle 90 degree. Okay. So the angle between phi equal to 90 degree. Therefore, power factor equal to cos phi equal to cos 90 degree equal to 0. Therefore, P equal to Pi cos phi equal to 0. Thus, your capacitor does not consume any power, does not consume power. Say the power expression. See, the small p equal to small v into small I. This can be written as phi max I max sin omega t into cos omega t. But what is sin omega t into cos omega t? That is P max I max, this is upon 1 by 2 sin 2 omega t. So this is the expression for power. Now from this expression from power, it is observed that power waveform has double the frequency as that of the voltage and current, and its value, the power over a complete cycle, whole cycle, is 0, because integration from 0 to 2 pi of sine 2 omega t dt equal to 0. Therefore, P equal to 0. So what is the conclusion? Conclusion is pure capacitor does not consume power. Okay. So the friends, in this way we have finished the alternating current flowing through pure capacitor. So here we have applied the small v equal to Vmax sin omega t across the capacitor plates. Then resultant current is given by I equal to Vmax sin omega t plus pi by 2. This is equation 2. From this it indicates that the current is leading the voltage by an angle pi by 2. Now the Im, maximum current equal to Vm upon Xc, where Xc is equal to 1 upon omega c equal to 1 upon 2 pi Fc, and is known as capacitive reactance, and it is denoted by, its unit is ohm. So thus Xc is inversely proportional to the frequency. Therefore its graph is as shown in the figure. So as the frequency increases, the capacitive reactance decreases, and it becomes 0 when the frequency becomes infinite. So from this equation 1 and 2, it is observed that current leads the voltage by an angle pi by 2. We have drawn the waveform also. Now see, we have to see the power waveform. See, during this band of the time band, the current is positive, voltage is positive. Therefore their product is also positive. Okay. Then during this band, current is negative, whereas voltage is positive, their product is negative. Then during this band, both voltage and current are negative, their product is positive. And here the current is positive, whereas voltage is negative, therefore their product is negative. So here also, when the voltage completes its one cycle, the power waveform completes its two cycle, and it has equal positive half and equal negative half, and therefore power over a complete cycle is 0. Okay, so we will stop here. Thank you.